All right, hello and welcome. In this video, we're going to look at how to calculate total series parallel inductance. So when we look at this circuit, you start at the top here. You see we have no choice but to go through L1. So we'll say L1 is in series with. We hit a node, so we can open a parenthesis there and say that something's in parallel. And if we travel down the first branch, we see that goes through L2 and ends us at our final ground location. So we'll say L2 is in parallel with. We'll go back up to that top node and we'll see where else it leads. And it leads down through this other branch, L3, and that also goes back to our final ground location. And so we'll say that L2 is in parallel with L3, and that parallel is in series with L1. So it's really, really important that we take the parallel of these two before we add L1 to any of them. Okay, so also one thing to note is the microhenries versus the millihenries here. And so we will end up summing these together, so we can leave these two while we do our parallel equation, and then we can deal with that after that when we get into our summing of our millihenry value. So let's do our parallel first. We know that we have two microhenries values, and it's going to be L2 in parallel with L3. And so we'll put those two in parallel. We'll say 1 over 1 over. L2 is 450. And over 1, we'll say that that is added to the 1 over of 1100. That's in a microhenry value. So we know that now in our LT equation here, we can say that we have L1 in series with, and then this value that we just got. So 319. And we'll keep microhenry there, close that off. And so now we know that L1 is actually 1 millihenry. And so we might want to move this 319 into millihenries also, so it's a little bit easier for us. Right now we know that we're at the -6 location. That's where our decimal point is. If we move it forward 1, 2, 3, put a decimal point there, that's that -3 location. So now we can say that we have 1 millihenry plus 0.319 millihenries, and that's going to allow us to sum them directly. Right now we know the answer. We know it's 1.319 millihenries. And that is our total inductance for the series parallel circuit. Let us know if you have any questions.